Hello, this is Mr. Persales, and I'll be doing the Graphing of Motion Lab Part 4. I hope you enjoyed the lab, being sure to change the type of graph, position time graph or velocity time graph, using the brake and the accelerator, and then changing the acceleration and brake types based on different types of cars, okay? And then initial speed, you had different types of animals here. For the entire lab, I left it on deer, but I hope you played with it, watching the car go back and but go forward, forgive me, and then what that looked like on both, again, a position time graph and a velocity time graph. So you went through the lab, several graphs to do, comparing velocity. Let's go ahead and look at part 4. Draw the graphs requested. Each has a line A and a line B. Even if you use two colors, please label them. So I do have red and black today, but I'm going to follow my own directions and try to label them as well. Okay. Position time graph. We're looking at constant position this time. Okay, constant position. A car staying at home. Well, the first thing we've got to decide is that we're going to call home 0 meters. But that's our home base. That's our frame of reference. And we stay at home. So at 10 seconds, we're at home, 0 meters away from home. At 20 seconds, we're 0 meters away from home. At 30 seconds, we're 0 meters away from home. And so we can just draw a straight line across 0. Notice, again, this is not a map. It's not like anybody's going anywhere. In fact, we're staying at home. We're 0 meters away. Please do not think of these as road maps at all. This is a graph, a line graph, with independent variable time and a dependent variable position. So a distance, position, time graph. Right? Oh, I knew that I would. That's line A. A car 500 meters from home. So you've gone over to a friend's house down the road and you've parked 500 meters away. So when the story starts, you are not at home, you are 500 meters away. And you hang out there for a while. Probably a lot longer than 10 seconds, 20 seconds, 30 seconds, right? At 10 seconds, I'm 500 meters away. At 20 seconds, I'm 500 meters away. At 30 seconds, I'm 500 meters away. In fact, all of this time, I'm just hanging out at my friend's house. At least my car is sitting there while we go about our business. So, constant position on a position time graph. Are you at the frame of reference? Are you 0 away? It's a straight line right across 0. Are you away from your frame of reference? In this case, home. And this up here, line B. All right, number 2, position time graph still. So position time graph still, got to be careful of that. Constant speed. So a car traveling slowly from home. In the lab, you had a Yugo, or I think maybe even an Edsel that you might have played with, moving very slowly. So let's make up some numbers. I started off at home. From home, my frame of reference, I'm at 0. And 10 seconds, I'm not that far away. I'm only 200 meters away from home. At 20 seconds, I'm still traveling. I'm 400 meters, right? So 200, 400. At 30 seconds, well, what point am I going to make here? 200 meters, 400 meters. What point should I mark if I'm traveling at constant speed? Well, every 10 seconds, it's going to travel 200 meters. Just slowly traveling away from home at constant speed. Right? Every 10 seconds, 200 meters. Every 10 seconds, 200 meters. Every 10 seconds, 200 meters. A car traveling quickly from home. So we had the Porsche and the Tesla in the lab. So that we start from home. So they too are starting right here at 0. But let's get him going. At 10 seconds, he's already at 600 meters. Okay? And traveling that at 20 seconds, he'd be off the grid, right? 10 seconds, 600, 20 seconds, he'd be up at 1200. Right? So we're going to have to back up a little bit. That's 600, so I guess 5 seconds would be right about at 300. 15 seconds, if it's 5 seconds for 300, 5 seconds for 300, 5 seconds for 300, it's going to be right up there. Okay. Constant position. Stay in the same place for the entire graph. 0 meters, 0 meters, 0 meters, 0 meters. Constant position. I'm away from the frame of reference. 500 meters, 500 meters, 500 meters, 500 meters. But if you're traveling at constant speed, are you going kind of slowly, like A? Are you going faster, like B? And notice it's a nice slope, right? It's not a curve or anything else like that. And again, 5 seconds, about 100 meters. 10 seconds, another 100 meters. 5 seconds, another 100 meters. 5 seconds, another 100 meters. 5 seconds, another 100 meters. Notice there's a constant slope or grade to this, right? But, y'all, it's not a map. It's not a hill. Nobody's going uphill. There's nobody walking uphill. So please be careful of this. This is a position time graph, and we read this very different than we would read a map. Do note this. At 15 seconds, the faster car is already 900 meters away from home. He's traveling fast. At 15 seconds, this one's only 300 meters from home. Not traveling as fast at all. In fact, a third of what this person's traveling. So you can read any point along those lines. All right, we're going to switch to a velocity time graph. We're going to go back to constant position, and we're going to go back to constant speed. But this time we're on a velocity time graph. So this one's kind of interesting. A car staying at home. Well, if he's staying at home, right, just staying 500 meters away, how fast is he going? Right, this is a velocity time graph. Velocity is measured here in meters per second, which you've done in the lab. Well, he's not traveling at all. He's going 0 meters per second. Oh, I switched. Let me do something. Okay. Wanted to try to be consistent with my colors. A car staying at home. I said it, but I didn't use the right color. I'm going 0 meters per second. Now in the end, I'm lucky I've not made a mistake. I got very lucky. Well, this is the same graph for B. Still just sitting there. He's not traveling at all. So he too is going 0 meters per second. They're not traveling at all. So please note, constant position on a position time graph is looking different, especially for that line B with constant position on a velocity time graph. I'd like you to look at line B. That's why I wanted to make sure the colors were correct. You look at constant position in both of these. Velocity time graph, constant speed. This is a velocity time graph. A car traveling slowly from the house. So it's left the house. 0 is not the house. 0 is a speed on a velocity time graph. He's going some speed. Let's put him at 20 meters per second. He's got a constant speed. So I guess at 10 seconds, he's still going 20 meters per second. At 20 seconds, he's still going 20 meters per second. At 30 seconds, he's still going 20 meters per second. Then we have a car traveling quickly from home, right, at a constant speed. Well, how fast is he going? Let's put him way up here. Okay, at 45. This is 45 in between 40 and 50. 45 meters per second. Going 45 meters per second at 0 seconds, right off the bat. At 10 seconds, still at a constant speed. 30, or 20 seconds, forgive me, 45 meters per second. 30 seconds, 45 meters per second. Wow, look at the difference between constant speed on a position time graph and constant speed on a velocity time graph. On a position time graph, we've got these slopes. The one that's steeper is faster. On a velocity time graph, the one that's higher is faster. Just read the numbers. I'm trying to be really specific about grabbing numbers so you can read these points. There's a reason you did all that math. You did it for science class. All right, one last one. Velocity time graph. This time it's constant acceleration. So it's accelerating, right? Going faster and faster. Speeding up or slowing down. We've learned in class that that's a vector. So it may not only be a magnitude or a number, but it also might be a direction. Well, here in this lab, it's a number, a magnitude. So a Yugo car accelerating. Well, let's start him off at 0. He's accelerating. The little Yugo, it's an old car. I think it's one of them that used to blow up from time to time. It was really poorly designed. Some small European car that was popular here in America for a bit. Okay. Well, at 5 seconds, he's got himself up to 5 meters per second. At 10 seconds, it's constant. Another 5. Another 5. Another 5. So then at 20 seconds, he's up to 20 meters per second. Actually, that's probably faster than Hugo goes. Another 5. Another 5. So at 30 seconds, he's up to 30. So look at all the patterns, right? 10 seconds, he's going 10. 20 seconds, he's going 20. 30 seconds, he's going 30. Over time, his speed keeps going up. He's accelerating. A Porsche-like car, right? I don't need to tell you what a Porsche is, or a Porsche, however I'm supposed to say that. All right, let's be crazy with this. Let's get him up to, at 5 seconds, he's at 15, right? Reading my graphs. So at 5 seconds, he went up 15, and another 5 seconds, he has to go up another 15 to 30. Another 5 seconds, he's got to go 30 plus 15, 45. Look at that nice straight line that's being formed. All right. Careful, y'all. Constant speed on a position time graph looks a lot like constant acceleration on a velocity time graph. Is it important to know which graph you're working with? Yes. Is it important if you're having trouble to look at certain points along the way? Yes. Is it important to go ahead and memorize this page? Yeah, I think so. Okay? Constant position, staying in one place on a position time graph. Constant speed, from a nice slope, right? You'd be moving further and further away from home, right? If you're going at a constant speed, a fast speed or a slow speed. Okay. Position time graph. Velocity time graph. What's constant position look like on a velocity time graph? Well, you ain't doing nothing. You're going 0 meters per second, so it's a nice straight line. Constant speed, right? It's velocity now, careful, right? Slow speed, faster speed. You're accelerating, right? Slow acceleration, faster acceleration. Look at those numbers going up. All right, hope you found that helpful.